Thanks for having me. My name is Spencer Wright. I do a couple different things. I work at a company called Topology, which makes really complicated design software for industrial 3D printing, primarily parts that are for the medical or aerospace industries and are made via metal 3D printing. I also run a manufacturing-focused newsletter called The Prepared. I write about manufacturing, supply chain management, logistics, all kinds of fun things. And as a kind of tacked on thing on the side, I run a company that came out of two successful Kickstarter projects. The product we make is called the Public Radio. It's a single channel FM radio. It's housed in a mason jar, which ends up being a remarkably advanced fulfillment operation for the simplest electronic project you could possibly make. So I have experience working across a wide range of hardware industries, and yeah, excited to talk to you, George.
Awesome. Okay, well, George, right now, since you're the only one, you'll get majority of the time. If someone kind of comes in, I may have to cut your time down. Normally it's 10 minutes per person, but right now you have the floor, sir. So
let's dig in, man.
Okay, and I'm gonna slightly mute myself just so you don't hear any of my background noise.
All right. Hi, I'm George. My project is called Estia Pi, which is a smart thermostat for homes. It looks like this. The case is like that. Is based on, the whole logic is around, is more like privacy for privacy concerned users, and is targeting the open source market. So the whole project is fully open source and open hardware. The case is 3D printed, and all the electronics, schematics and the PCB and all that are published on our website. So this has been going on for 3 years or something like that. And right now we're running a crowdfunding campaign, which is already funded. So it's, I think there are 15 more days to go. So this thing is gonna go ahead. And the reason why I chose you for this mentoring session is because I have a few questions on, if I could have some suggestions from your side on how I can move to the next stage, basically. If I could just make a little intro. That's the board. It's based on, where is it? Over here. It's based on Raspberry Pi. That's a power supply. The relays that control the various elements of the heating, the furnace, the fan, and all that. It connects to your Wi-Fi, and you can control it from your smartphone. That's then a touch LCD that snaps on the header. So this is everything. All the electronics are here, and let me get some more light because I think you can't see very much.
Great, yeah, thank you.
The LCD fits here, and that's the back plate, which is also 3D printed. This is a translucent filament I've used for testing. It gets fixed with nuts and bolts, which is not great, but it works. And so this whole thing snaps at this part, goes on the wall, and then the front cover snaps on the back plate. The design is working. It's not great. I mean, with 3D printing, I had quite a few limitations, and I had to work around these. So for this campaign, what I'm gonna do is everything is gonna be done in-house. Nothing is gonna be sent over to China or something for a proper production line. But this is gonna be my first feedback, so I can go around and ask for quotes and all that. What's gonna be needed. What else? I have some notes that I want to mention.
Well, let me kind of ask a clarifying question there.
Sure.
So you said you're going to do it all in-house. Does that mean, I mean, you're going to hire a PCBA shop, presumably, and then do hand assembly and printing and everything yourself? Is that right?
That's right.
Okay, got it.
Not all of them is going to be by myself, but mostly yes.
Sure.
It's going to be by hand, if that's the question.
Yep. And
yeah.
And how many?
Yeah, I was just about to go on.
Yeah, go ahead. Go ahead. Yeah.
I think it's going to be something like 150, maybe 200. It's going to be more than that with the orders that are going to come in. So yeah, we're talking about a batch of total 200 pieces. I'm quite optimistic because right now it's summertime and I'm selling something which is targeting hitting basically. So I don't think it's the best time of the year to sell this thing. I mean, I've seen, I know my figures from the last years. Usually during the summertime, sales go down and then pick up by October, around October. So yeah, I think I will need to speed up things and find a solution right after the campaign is over, because I think I'm going to be needing a proper system set up with. I don't want to be doing all the hardware by myself, so this thing will be outsourced, if I can say outsourced. But yeah, this is the current state. I have a few issues. One is while I was trying to save space, Are you doing electronics and stuff like that? Are you?
Yep. Yeah.
Yeah. So I was trying to save the height of the total height of the board.
Yep.
Can you see here? So the LCD is one thing that is definitely gonna be in the height of the device, and because it snaps on the header of the Pi, to avoid making the PCB even bigger, I'm trying to reuse the header of the actual Pi. So I want this to snap right on the Pi to avoid soldering and making an extra header. So I'm doing this, but can you see? I cannot even see my video.
It's a little bit hard to tell from that side. Can you take it a little bit farther away from? Yeah, right around there. Let's see. Yeah.
Okay.
Okay.
So that's the LCD and that's the PCB. Putting them together, you hit the relays over here.
Got it. Okay. Yeah.
So I have this little issue because the LCD is actually stuck on the front cover of the case, and the PCB is stuck on the back plate. And because it's 3D printed, it's not always exactly on the spot, and you already have a gap which is not. Can you see here?
Yeah.
It's not put all the way in. So I think what I'm gonna do is I'm gonna have to remove the header and add the longer pins. The problem is because I'm using Pi 0W. Do you know the problem they have with the quantities?
No. I haven't used that one.
Pi Zero is a very popular one for in the manufacturing, in the DIY area.
Okay.
So I want to go with Pi Zero W. The thing is, because they messed up the pricing, they couldn't sell more than one per customer. So they came up with a new model, which is WH, and H stands for headers, which they have the headers pre-soldered. And they made a different price, and now they can sell as many pieces as you want. So the thing is, if I want to have many Pi Zeros, I need to have the one with the headers pre-soldered. So here's my problem.
Got it.
I already have the
Okay.
headers, and
Got it.
remove.
So sorry. So for part availability reasons, you want to have the headers pre-soldered, but for mechanical assembly reasons, you want to have the headers not soldered.
Exactly. So I can solder longer headers.
I mean, what can you just move the relays down? I mean, it looks like you have a little bit more room on the top and bottoms of that hexagon.
Yeah, this is it. And you need some space for the screws that will be fixed to the wall. And if I just place this there, it's not much. It's not much. And if I want to go ahead and make this done in-house somewhere, outsource it, remove the headers and adding new headers, I don't think this is going to be possible or even cheap. It's too
that's
much.
not going to be popular. No.
So I'm a little bit stuck there. Not stuck, but it's not foolproof. You can place the cover in a way that the LCD won't be plugged in all the way in as it should.
Yeah, that's tricky. What's I mean, you could mount those, mount the relays on their side or something like that. But you have a little daughter board, like an edge connector or something like that there. And I'm not sure if you haven't saved any space though either. Are they shorter? They're probably shortest in the orientation you have them now, right?
Yeah. It's not I came here just to ask that, but I'm just reporting trying to solve right now.
Yeah, that's tricky.
I can find maybe different relays as well, but I have the power supply, which is a little bit shorter, but by the way, this is the EU version, which the power supply runs on mains, which is from 100 to 240 volts.
Yep.
But for the HVAC, the regular US house, there is a different power supply, which is 24 volts AC. And this is actually higher than that. It's just around the height of the solid state relays. So maybe I'll need to change too many components and completely the PCB. I'm not sure. I'm trying to find different options, what's going to be the cheapest and the fastest or the safest.
Yeah.
Yeah,
that's tricky without making it physically larger.
Exactly. I want to keep the case, because the case, I think
looks pretty big. Yeah. Well, let me think about that for a minute.
As I said, I didn't come here for you to answer it. I'm just reporting what's the issue here.
Yeah, got it.
Yeah, one problem with that, the thing with the LCD is not always 100% in place, and the other is with the 3D case. I'm trying to see if there's any alternative I can come up with injection mold for a reasonable price. And this design straight away is a no-go. This is not
Yeah.
possible to be done that way. So
Yeah.
the major
The other thing that and you kind of alluded to this earlier, but the other thing that I would be concerned about is nuts and bolts.
and mains.
Sure. Yeah. Yeah. I mean, but to me, I mean, just I guess from an assembly standpoint, since you're doing this yourself, I mean, you'll be fine, right? 200 times 4, whatever they are, M3 nuts and bolts isn't that, it's not going to kill anybody, right? But it will get frustrating, especially the more you have to take things apart and put them back together and so on and so forth. Designing any kind of features you can design in to have the thing just kind of snap together, that
Because it's really printable. I may add like little hooks around here that can maybe slide in the
exactly
pieces. Because I don't know if you saw,
or push in, right? I mean, they could be things that do this when you push when you push the thing in, they just kind of spread and click like your main. Exactly. Yeah, precisely. Yeah, but the opposite, obviously. So yeah.
The LCD was with like hooks like this before, but now I changed the design and you just throw it in and turn it and
That's nice.
Stays there.
Yeah.
But for the PCB, maybe I need to come up with something else as well.
Yeah.
I need strong, like, because the wire sometimes they may be like big wires. In some houses and you do have like 6, so there's going to be some tension here, and this needs to stay in place. If pushing up is releasing the PCB, this may happen when you connect to the wires. So this going loose with mains connected is no fun. Oh, by the way, I forgot that this is the sensor, and in order to move the furthest away from the CPU, it has to go on in a wire that goes in a special design pocket right here to kind of insulate it from the heat that comes from the CPU, but also get lots of air from the outside. So this is
got it. Okay.
This is over here.
Yeah.
It's kind of hard to.
Yeah. And is that wire assembly off the shelf, or is that something you're making?
The what? The wire.
The wire assembly, yeah.
The wire is ready, yeah. Thank God.
Good. Okay, good. Yeah.
The first like 50 units have been done by hand. Like I've soldered DuPont wires, and oh my God.
It's the worst. Yeah. Yeah, it's the worst.
If you get them right, it's already a pain in the ass.
Again, it's only 200 units. Like that won't, the plugging things in, and it looks a little fiddly, right? That probably won't kill you. I will say, getting rid of wires, it's really good. If you can get rid of wires, that's a good thing.
The thing is, if I place the sensor anywhere
sure,
is too far away from the outside air, which is the most important thing. And secondly, of course, you get some heat from the pipe, which is, if it's a 24/7 time, over time it builds up, so you get 5, 6, 10 degrees reading off the actual value. So yeah, it needs to move.
Yeah, I totally hear that. I wonder whether you could figure out, have some compensation model and say, hey, also, it's kind of like, so what, right? I mean, if, like,
I know what you mean exactly. I've gone
In a way, it kind of doesn't matter, right?
I
But
have a I have a table with different ranges of temperatures. So between
yeah,
60 to 65, it's off, I don't know, 2, and then 3, and then 2.5. I have this table. I didn't
yeah,
implement it. I want to be try to make it as close to realistic as possible. Right now is less than 1 degree. So
that's
now
nice.
goes into the so what
Yeah,
area, which is, yeah, I mean, when you change your thermostat to your home, maybe, yeah, you will get a different reading, but after a week or two, you know that your desired temperature is going to be X. So you
exactly.
do that, and then you
Yeah,
forget about it.
yeah, yeah. I guess I mean it's a question of how much you care, right? I mean, because it's it's going to cost you, whatever, 2 minutes of your time, and I mean, because the wire assembly isn't free, right? I mean, presumably you could hit that temperature sensor and just drop it onto your PCB, right? Um, so you have some actual financial cost, and then you have your time spent assembling the thing, and whether that's worth it to not just apply your compensation model or don't, or whatever it is. um, not that you shouldn't take your users and customers desires seriously, but you might act when you realize, like, yeah, it really doesn't matter. If I yeah, like my learned desired temperature is whatever it is, and that's just fine. So yeah. um what else? It,
Um,
I wondered, I just stepping away from manufacturing for a second. I mean, I wonder what your perspective um, on the need for connected thermostats is. I say as somebody who actually just purchased a bunch of connected thermostats, and in a way, I kind of don't even know why I did that. Uh, I almost bought a smart doorbell and then decided, like, that's dumb. I should just get a regular doorbell, because usually if I order seamless, they call me anyway. They call my phone anyway. So they're never going to get to my smart doorbell. And I guess I wonder um, what you see as your, yeah, what's your use case, or your or the need that this product is fulfilling, I guess.
yeah, the first one is I think it's DIYers.
Yep.
First of all, it's this thing you can make it yourself, or you can
Yep.
buy it as a kit and make part of it yourself.
Yep.
Which all these options are available on the crowdfunding campaign and or on our website before starting the campaign. Second is privacy, because the Raspberry Pi is running everything locally inside it. All your data are stored right here. There's no cloud, there's no internet required, there's no third-party services, there's no paid services, there's nothing extra. Of course, you need to do some extra stuff, which most of the time is done by me, so everything is kind of ready here. If you don't want to really set up and install servers and all this kind of stuff, this comes ready with all these features. And the third, and I think the most important, is because I'm using OpenHub, which is another open source platform for home automation. This adds, not sure if you heard of OpenHub before.
I haven't, no.
It has a great range of extension. With, I'm talking about like maybe thousands of existing gadgets and devices that you may already own, from lights, smart lights, to sprinklers, to doorbells, to heating systems, to, I can't remember. It's a huge list with
Huh.
the community is great, and they keep adding new features into it. So once you have this running, this is your like hub. And if you have like a smart light, you can add it in your house in minutes, and it can interact with from your phone. You can control your lights and the heating and maybe your shades and the blinds and all this kind of stuff, and yet they can interact with each other. So this is becoming a hub for your starting or continuing your home automation projects. Home automation, I'm not saying is for everybody, obviously. As you said, doorbell, smart doorbell, to me as well sounds a bit dumb. But I'm just showing the way, I'm showing the options, and if people want to go there, the possibilities are endless, if I could say that, because if you're really gonna go into these things, I mean, there are too many combinations and scenarios you can start building. Going through the community of the Open Hub, people over there have built amazing stuff, and sometimes maybe you feel that, oh, maybe I am missing out. And if you are this kind of person that you want to experiment and play with things, then yeah, this is gonna be a great toy for you. But I'm not saying this is for the average customer. If someone wants to go ahead and buy a Nest, probably they will go ahead and buy a Nest. If they want the looks, sure. I'm not targeting to everybody. This is a kind of niche market.
Yep. Yeah. I'm actually just looking at Open Hub as you're talking about this. This is pretty cool. This is an interesting an interesting platform here. I like this. Yeah.
I'm actually donating part of the campaign money to them, back to them when it's done. I don't work for them. I'm just trying to say thank you because most of the functionality is from them. I'm just basically combining electronics, the case, and all the configuration and the installation of the software for people who cannot do it or don't want to do it, don't want to lose time, because there are too many little things that can go wrong.
Yeah.
So,
well, I will say I looked at your documentation and it looks really great. You have done a pretty good job putting all this stuff up on GitHub. You have firmware, you have embedded hardware files, you got STLs.
That's my main target. I'm not, okay, it sounds a bit dumb, but I'm not really trying to sell it. I'm just trying to make it easy for like people who are not experts in all the areas that are required. Maybe get some help in the area that they're not that great. So yeah, that's why the documentation is. I'm not saying it's perfect, but I think people can.
It's comprehensive though.
Yeah. And this is not the model that is actually advertised on the crowdfunding campaign. This is the one just before.
Got it.
And all the features that are advertised on the campaign are tested, but they're actually being done right now. So once the campaign is over, they will be finished and released.
Got it. Yeah. The one thing I would say, and this is just a quibble, I guess. To me, as a mechanical designer, I think of STLs as compiled code, right? And STL is not an editable thing anymore. It's the result of your design intent rather than your design intent itself. And so, in as much as like if you want the physical enclosure to be hackable, if you want to encourage people to for instance, like design a better place for the temperature sensor to go in this housing, or make it easier to assemble the entire thing together, I would really encourage you to at least put up step files, if not, the original, the native CAD files, whatever you're using.
It's not open. I'm designing it in how's it called? It's a web-based tool. I forgot the name. It's a very popular one.
Yeah, Onshape.
Yep, exactly. Onshape. And there's no file I can share the link,
You can
the
share the
design.
link though, right? Yeah, so it actually is open. The design actually is open source, right?
Yeah.
Because the way their pricing model, and they may have changed it recently, but I think the pricing model is that they're free for open source projects, but then once you close your
In public.
design, then they start charging you money.
That's
So
right. Yeah.
it's possible that you can actually share the source link, and what you can just do is go into your Hestia touch case repo, and just in the README somewhere, just say, you can't host the actual file on GitHub because that's not how Onshape works, maybe, but
Yeah.
at least you can link out to it or something like that, and so you have the pseudo compiled code of STLs in the repo, but then a link out to the actual source somewhere
I
else.
tried to redesign the case in a proper open source software, but it was just nightmare for me, and it was just too
It's
much.
not worth it. Yeah, Onshape or Fusion 360. I mean, both of those are so accessible, and they're approachable for somebody with a mechanical engineering background, and also usable by somebody who does not have that background. So,
True.
I think that's the right place to go. Yeah.
For the level that the depth you need to go for this case, I think Onshape is more than
Yeah.
fine.
Yeah. That's great. Yeah.
Okay, just going to I've used all the time. Wow, I'm alone
Yeah.
now. I have 20 more minutes. By the way, it's 20 to 12 over here in
Yeah.
Athens.
Yeah, we'll just give, so I'll just have some last announcements at the end, but yes, you're good. Hopefully this is helping you.
Okay. So my last thing is because I'm thinking about, as I said before, moving it to the next level after the campaign is over.
Uh-huh.
I just want to ask you if you have any suggestions in like companies or countries I should look into, because I think there are too many. Just by Googling around, you get way too many possible candidates that I can send over the electronics to be done, or
Yeah.
all this kind of
Well, where are you based, first of all?
Greece,
In Greece.
Europe.
Okay. I mean, I think that you're going to be doing your final assembly in-house, and there are
Is that
still some
suggestion,
things.
or
Oh, go ahead.
is that your suggestion,
No,
or
no,
are
no.
you?
For your 200 units, you said you're going to be doing the
Oh yeah,
actual
yeah.
hand
I'm
assembly
not
yourself.
talking about. I'm not talking about this batch. I'm talking about after the campaign is over.
Oh. Got it. Okay, got it.
Basically, I'm trying to focus just on the R&D, and I don't want to be doing anything that has to do with the orders.
Yeah, got it.
So far, I've been doing everything by myself, so it's taking too much time from the R&D, which is not
Yeah,
fun.
yeah, there's always an inherent thing there. If you're good at R&D, you get stuck with production, kind of. Yeah,
That's
and
where.
you got to decide whether or not that's your that's your goal, I guess. I mean, if you're doing thousands of units annually, um, that can be really hard. So the electronic product that I sell, we do thousands of units annually. We've figured out a way to make it work. We convinced a PCBA house to do our mechanical assembly and testing and programming and fulfillment. And we manage all of those tools, right? So they're not a proper contract manufacturer in the sense that they take over the entire thing and own all the infrastructure around building the product.
Mm-hmm.
Instead, I am the manufacturing engineer. I maintain all of the software, hardware, infrastructure, and a bunch of the procurement that goes into making our product, because they're very good at buying things from DigiKey. Like they have those accounts set up. They are better at it than I am. I hate the DigiKey website, right?
Yeah.
They know how to navigate it very well. So but they're not as excited about procuring a custom component that's not even electronic from a tiny little vendor in Taiwan, right? So what that means is that you still end up handling some aspect of your production, right? Like I submitted a purchase order today for another batch of boxes, cardboard boxes, because that's just one of the things that we supply. And that's because we're in this range where, we're doing a couple thousand units a year. It's too many for me to do myself. And it's too little. Yeah, it's too little to have a contract manufacturer that just like spits out products, in the tens of thousands. So I think that my advice, and this might be of limited use, is to really be explicit with yourself about what scale you want this product and this business to operate at, and then make decisions that work towards that. And what that means is like really like getting comfortable with the idea that like, okay, I'm gonna try and sell X number of these per year. And every decision that I make about this product has to serve that goal, right? That might mean that you make decisions that you're not super happy with. I have built thousands of single station FM radios that are housed in mason jars myself. And that meant converting my basement into a production line for more than a year, So that was a lifestyle choice that I had to make that was based on the idea that I was going to have this business that was going to be kind of on the side of what I do normally, where like I want to be focusing on other things, but I also want this product to live, and I want it to succeed in at least some scale. So I mean, this is not that useful, I feel like, but it's a tough thing to come to terms with. In many ways, I haven't still come to terms with myself, I think. But it's also, I mean, I think that I have kind of gotten to the point where I'm like, there are actually some really interesting problems in operating a business that ships thousands of units per year. And
absolutely.
and I tell you what, I think that like you as an R&D engineer could probably figure, like you will get you as the line worker will get pissed off at you as the manufacturing engineer or the design engineer for having that wire assembly. That wire assembly is going to piss the part of you off that is actually assembling units, and it'll force you to redesign it, right? And there is something kind of perverse and beautiful about that in a way, but yeah, you do have to make choices that allow you to spend some time in both of those worlds and not get burned out. So best of luck. It's not impossible, but it does require you to be really clear with yourself about what you want and be willing to make decisions that might hurt in order to actually achieve that.
I don't want to be any kind of advertisement, but do you have any companies you could direct me later to start maybe some contacts and get quotes or something like that?
Possibly, yeah. We'll follow up by email or something.
Okay. Okay, I think that's it for me for today.